Welcome to NASA's Jet Propulsion Laboratory in Pasadena, California. I'm Veronica McGregor. We're here for another very exciting event that's going to take place just 5 days from now. We are attempting to land another mission on Mars. And this mission is like no other that we've sent to the Red Planet. This mission will be studying the deep interior of Mars to tell us more not only about Mars, but also about how all rocky planets formed, including the Earth. Our landing time is Monday, November 26th at about noon Pacific time, 3 p.m. Eastern time. And I want to give you some websites immediately because I want you to bookmark these so you come back on Monday and you watch the landing live from Mission Control. If nothing else today, please book nasa.gov/live or either one, go.nasa.gov/InSight Toolkit. The InSight Toolkit will have a link to multiple ways that you can watch on live, both on NASA and on social media channels, including a live feed from Mission Control in 360 degrees, so you can feel like you're sitting in there with the rest of the mission team. Our event today is going to be divided into two parts. We're going to spend the first hour talking with mission managers about how InSight will operate on the surface of Mars, and also tell us a little bit more about the white knuckle event that will take place Monday with entry, descent, and landing. Following that, we're going to have the science panel. That will start at 11 a.m. Pacific time, and they will describe how these instruments that we're going to place on the surface of Mars will be able to take the vital signs of the planet to tell us more about rocky planets. I'm going to start now by introducing our first guest, and it is Dr. Thomas Zurbuchen, and he is the NASA Associate Administrator for the Science Mission Directorate. Welcome.
Thank you so much. Hi, everybody. Well, I'm so excited to be here, and of course to recognize that InSight is part of the NASA science program. Over 100 missions exploring our planet, our star, the sun, planets elsewhere in the solar system, but also worlds well beyond our solar system, asking questions that are really hard, such as, where did we come from? Is there life elsewhere? With this program, with the many missions, we explore the secrets of the universe, and we enlarge the space we live and think in. With this program, we also protect and improve life on Earth. And we think of the many people that were affected by the catastrophes here at this coast, but also elsewhere on Earth, in which we have a direct impact in a positive fashion. And we're so glad about it. InSight will join these missions that you see up there at Mars, a history, and please for the second visual, a history of exploration of this neighboring planet. Going to Mars is really hard. As humanity, the explorers all over the world, we're batting about 50% or less of successful missions there. The exciting part is here, though, we're building on the success of the best team that has ever landed on this planet, which is the NASA team with its contractors and its collaborators. InSight will join the missions that are out there that have since 1965 at the first flyby. And it will join missions that are already there, roaming around the surface and flying around it. And of course, you read that just a few days ago, we actually announced where Mars 2020 will land on this exciting planet. And frankly, we're really looking forward to that, and also think beyond that as we go to the moon now and eventually to Mars with humans. We will, of course, take advantage of all the knowledge we're gaining right here with these robots that are there, and really teach us everything about this environment that we can then benefit from. Right now, everything is about InSight, though, because this exciting mission is on the way there, becoming an active mission on the surface. And the person who has most to do with this, frankly, is the project manager, Tom Hoffman. I'm now happy to introduce to the stage. Thank you so much.
Thank you very much, Thomas. I cannot express to you how excited I am to be standing up here today to talk with you. Just 5 days from us landing, my heart is beating inside of my chest like a drum. I've been working on this project for 7 years, and to be literally just 5 days from landing and starting to get the science that we've been working so hard for, to me, is absolutely thrilling. I'm so excited. I can't even express to you how excited I am. So we launched May 5th of this year from Vandenberg Air Force Base. We were the very first interplanetary launch ever from the West Coast, and being a West Coast guy, California native, very excited to break the monopoly that Florida has had on launches to other planets. So we've been journeying to Mars. We've gotten about 295 of the 301 million miles that we have to go. We've gone almost the 7 months that we need to go, just 5 days left. But we can't do that alone. We have been working with, really, as Thomas said, the very best partners across the globe for this mission. So if I can get the first graphic here, you can see we have domestic partners that largely built the spacecraft. You'll hear from Stu Spath coming up. Lockheed Martin is the main spacecraft vendor. We have components from many other domestic partners, but the instruments were all built largely by European partners. We have representatives of those that will be talking in the next talk. In addition to that, the science team is made up of people across the globe. So you've heard the expression, it takes a village to raise a child. It really takes the whole globe to build a breakthrough instrument like we have today with this InSight mission. So with that, I'd like to go to the next graphic. So we've been cruising to Mars for about 7 months. What we've been doing on the way there is we've been doing trajectory correction maneuvers. Those are designed to get us targeted to exactly the right spot in the atmosphere that we need to be in order for us to land where we want to land on Mars. So we've done 4 of those so far. We have 1 more potentially to go. You'll see that we have TCM-6, so you say he can't count. We actually had an opportunity to skip one of them because our navigators did such a good job. We didn't do TCM-4. We're working right now on TCM-6. We're actually looking really good. We might even be able to skip that one because, again, the navigators have done such a great job really targeting us for where we want to be. So we're going to keep working on that for the next several days, working on the trajectory correction maneuver, working on the final parameters that we're going to need to do once we get to do entry, descent, and landing on Mars. So we'll be updating those over the next few days. So while everybody's off having turkey tomorrow, there'll be a bunch of people here at JPL working all day long, hopefully taking a little bit of a break for a turkey dinner, but largely working to make sure we land successfully on Mars. So when we get there, we have lots of ways we're going to be communicating during the entry, descent, and landing process. So far, we've been talking largely with the DSN, with the spacecraft. We'll continue that all the way until we get right up to entry. At that point, we'll drop off our cruise stage, and we'll be using our UHF antennas to talk to MRO, Mars Reconnaissance Orbiter. That's our main method of communication for knowing that EDL went successfully. But MRO does not have real-time capability to send data back to us so that we know exactly what's happening right when it's happening. So in order to have that, we brought along 2 CubeSats called Marco, which Andy's going to talk about in just a little bit. Those will be actually giving us real-time information as we go through the entry, descent, and landing process, getting through the parachute deployment, heat shield separation. Marco is going to be telling us, hopefully real-time, that that's happening. Once we land successfully, then we'll also have Odyssey, which is another orbiting asset at Mars, which will come by later and tell us that our solar arrays have successfully deployed. So really, we're using all of those assets there to make cell phone calls, essentially, to get back to Earth. So let's go to the next video, and you can kind of see what happens on our entry. You can see InSight here in the middle. The 2 Marcos that have been following us the whole time, the whole 7 months, will be tracking us as we do our entry, and you can see Mars Reconnaissance Orbiter, or MRO, kind of coming up and catching us as we go through the entry, descent, and landing process. So that is basically how we're going to do the communication. So it's going to be very exciting. We have lots of different ways to be hearing from InSight as we go through entry, descent, and landing, and then once we're on the surface. So what I'd like to do next is introduce Stu Spath, who's the project manager for InSight over the last 7 years. So, Stu?
All right. Thank you. Thank you very much, Tom. Lockheed Martin is, of course, thrilled to be part of this mission. It's been a while going to the Red Planet, and with just 5 days to go, we are very excited. As Tom said, I've been on since the get-go with Tom 7 years ago, so I do have a lot of blood, sweat, and tears invested in this, and I'm looking forward to a nice, safe touchdown on Monday. If we could roll the first video, please. Our role at Lockheed Martin is to design, build, test, and operate the vehicle. Here you see us lowering down into the thermal vac chamber, and here's a video of us installing the heat shield, the protective thermal system that keeps us safe during the atmospheric entry. That was right before we shipped to the launch site. The image you see here now is kind of the fully dressed out version of the lander in the Denver High Bay. Let me give you a few fun facts about the lander. It stands about 3.5 feet high, or a little bit over belt high to the technicians that you see working on it right here. The length, tip to tip, from solar array end to solar array end is about 20 feet or so, which is about a 75 Lincoln Continental. And I should know, my dad drove one for 10 years. And the mass is about 830 pounds, so maybe think about a Harley Davidson, if you will. That's fully fueled. We will spend about 100 pounds of fuel getting to the surface during our descent and landing. One of the critical things after we touch down, of course, is power. So the solar arrays, as you see in this image, are a critical portion. So if we could roll the next video, I'll talk a little bit more about power and the solar arrays. This video is a time-lapse version of the actual deployment in our Denver labs. And you can see them unfurling in this shot here. This is obviously much faster than will happen. What we'll do when we touch down is wait till about landing plus 16 minutes with no solar array deployment. The reason we do that is we kick up quite a bit of dust during the landing process. So we want to give that a chance to settle out for 16 minutes, and then we'll command the deployment for about 16 minutes further from there. You see a nice close-up of the solar arrays there. It's interesting to know that that the solar arrays have 3,200 individual solar cells on them. So it is quite an effort to get those all installed, and then they furl up like a Chinese fan, if you will, tucked up under the lander. The power of the solar arrays is about 1,800 watts on Earth on a nice, clear, sunny day. But unfortunately, Mars is not Earth. So at Mars range, we're actually only about 600 watts, which instead of a hairdryer, 1,800 watts, it's more like a blender, 600 watts at Mars. And on top of that, Mars typically has a fair amount of dust in the atmosphere. So when you take that into account, we're more like about 300 watts, or a little cake mixer. So a mission like this on a cake mixer power is a big challenge. And we achieve that by sleeping a lot. About 90%, greater than 90% of the time, the spacecraft is actually asleep, and the science instruments will be on doing their business, and we'll wake up for communication passes and health and status checks. If we go to the next video. Obviously, landing is what we're all about here today, and so let me point out a couple of views of some of the key landing components. Tucked up underneath the lander here is the main component. That's the landing radar. It provides us the altitude above the surface, and any good pilot will tell you it's tough to land without knowing your altitude. So that's a pivotal part of the equation. These instruments right here are our descent thrusters. We have 12 of those. Each of them is about 68 pounds of thrust, and they pulse about 10 times per second to softly slow the descent and get us down to about 5 miles per hour at touchdown. So that's a pivotal part. And finally, the legs here, you see it's a tripod system, 3 landing legs. Think of those as shock absorbers on your car. As this touches down, those absorb the touchdown velocity, and they can actually compress up to 10 inches, which will account for slopes and terrain, et cetera. Tom briefly talked about the communications. This is the direct Earth medium gain antenna, and over here is the UHF antenna that does send the data up to Mars Reconnaissance Orbiter and Mars Odyssey. We work closely with those teams, the spacecraft team operating back in Denver, and the teams here at JPL are closely in coordination with the InSight team to make sure we get all that data back. So that's kind of a snapshot of what the lander is all about, and to hear more about the actual timeline of events on landing day, let's go to our EDL lead, Rob Grover from JPL.
Well, I have the great privilege of leading the EDL team, which is comprised of some very talented people, not only from JPL, but also from Lockheed Martin, Stu's organization, and also the NASA Langley Research Center and NASA Ames. And the team has been working for many years to make sure that the landing goes successfully on Monday. And of course, EDL means entry, descent, and landing. And that means that the team is responsible for taking the spacecraft from the top of the atmosphere all the way down to the surface. And we're going to enter the atmosphere at 12,000 miles per hour after our journey from Earth to Mars. So you can, that is a very high speed. And the whole purpose of the EDL system is to take that very high speed and down to 5 miles per hour when we get down to the surface. And that all happens in 6.5 minutes. And that's going to be kind of the main event on Monday. And I want to spend a little bit of time walking you through what to expect, what's going to happen during those 6.5 minutes from the top of the atmosphere down to the surface. So I'd like to roll the animation, please. So we will approach Mars, and the first thing we do is get rid of our cruise stage, which will be about 7 minutes before entry. We enter the atmosphere, and of course at 12,000 miles per hour, we're going to generate a lot of heat, up to 2,700 degrees Fahrenheit. When we get down to 7.5 miles or so, we'll deploy a supersonic parachute, which is about 39 feet in diameter. That'll provide a lot of the remaining braking for the system before we get to the surface. We drop the heat shield off 15 seconds after we deploy the parachutes, and then the legs spring open 10 seconds later. Our radar starts looking for the ground, and when we're about a little less than a mile above the ground, we separate from the parachute, fire up 12 descent engines, and those provide the rest of the braking and take us down to the surface. We have a constant velocity phase, which sets us up for touchdown. And you can see we will then make a soft landing at 5 miles per hour. And so there's a little bit of time where the dust will have been generated, and so we'll wait for that to settle. And we'll actually take a first image shortly after we land, and it may look like this if you go to the next image. And this is what it will likely look like a very flat place. Our landing site is Elysium Planitia, which Elysium means in Greek an afterlife paradise, although that may not look like paradise, but it is very flat, which Planitia means flat. And so it's an excellent place for a landing. As landing engineers, we really like this landing site. It's flat, it doesn't have many rocks. It's a very safe place to land. Once we've landed, once we've touched down, we're not quite done yet. In order to be completely successful, we have to deploy a set of solar arrays. And if you go to the next animation, you'll see a deployment. The solar arrays will deploy, they'll be commanded to deploy about 16 minutes after we land, and the deployment should take 16 minutes itself. So we should have the arrays out about 32 minutes after landing, and we'll get actually a confirmation of that about 4 hours after landing that we know that they're successfully out. We have a bunch of activities going on this week as we approach Mars, as you can imagine. And one of the important ones is we have a team of weather forecasters, basically a team of atmospheric scientists here at JPL, who are giving us daily weather forecast, or kind of the expected weather at Elysium Planitia on landing day. In fact, I just came from the morning weather briefing. We have it every morning. And I want to, they actually use the MRO spacecraft to actually take temperature measurements of the Martian, of the globe, basically, and generate basically a weather map of Mars. And I want to show you that in the next animation. This is a temperature map, and the orange and kind of yellow areas in the temperature map of Mars show dust activity. So we use it to observe whether there's dust storms going on. And in this animation, this starts back in early November and shows up until a few days ago. And you can see there was a regional dust storm down around the South Pole, down at the bottom of the map, and that slowly dissipated. But over on the right, you can see the InSight landing site, and it has remained very stable, and the green means kind of background conditions. And so for the last month or so, things have looked really good. If you go to the next graphic, which is, looks like we may have skipped one there. There we go, okay. If you go to the next graphic, this is our most recent weather map. So this gives a good indication of, in 5 days, I think probably, we're hoping it'll look much the same, but it's very across the whole globe, there's not much dust activity at all, so we're expecting to have a very plain day on Mars for the landing, and we're very happy about that. And in fact, we'll probably be surface temperature when we land. It'll be about 4 degrees Fahrenheit, so it's going to be nice and cold. And so it's definitely, probably don't need an umbrella, but you may need a coat, and definitely recommend a spacesuit too if you're there at the landing site. In addition to observing the weather this week, we're also paying very close attention to where we're going to land. And so if you go to the next graphic, we had just finished our last course correction maneuver last Sunday, which was TCM-5, which is the first time that we've actually been very close to our landing site. And actually, if you go to the next slide. Well, okay, so we have, up until TCM-5 on Sunday, we were about 100 miles away from our landing site, our landing ellipse. And since we've executed TCM-5, our ellipse has moved now very close to our desired landing target. Right now, or at least in our latest, or at least our navigators are telling us that we're about 4 miles away. So we're very close right now. And as Tom mentioned, we're going to continue to watch that this week. We're going to get more tracking data, and the ellipse is probably going to move around a little bit. It'll get a little smaller as we get more information about our trajectory. And we may not need our last course correction maneuver, which is scheduled for Sunday, and we'll make that decision at the end of the day on Friday. So we're very excited that our landing ellipse is now very close to the right location. So it's a great week. Things look very good for the landing. The weather's cooperating, and we're very close to our landing target. So we're looking forward very much to Monday after many years of work. So I'd like to now introduce you to Anne Marinin, who is the Marco B mission manager, and she's going to tell you more about Marco.
Hi. So Marco is a mission that launched with the InSight spacecraft, same rocket, different mission. And Marco, it's a mission of 2 small satellites that will fly by Mars on November 26th, the same day when InSight goes through its entry, descent, and landing. That was no accident. Marco is a technology demonstration mission. So the purpose of Marco is to fly 2 small satellites for the first time in deep space. It's the first time that satellites about the size of a briefcase have flown by themselves. Well, people on the Earth are actually operating them, but they're flying by themselves in deep space for the first time. They've been on orbit, in a heliocentric orbit, for about 200 days today. And right now, both spacecraft are working. The team is thrilled. And there are a lot of firsts with Marco. So Marco has to make its own way to Mars. It has to do essentially the same thing that the InSight spacecraft does on its cruise. We had to go through trajectory correction maneuvers. It has to generate its own power. We have to talk to the Deep Space Network. And talking to the Deep Space Network and doing all these trajectory correction maneuvers in deep space it's the first time that this has been demonstrated on a CubeSat platform. So the team is very excited. And if you play the animation, one of the things we hope to demonstrate now that the Marco satellites are still working is a communications relay architecture with the InSight lander. So as InSight goes through its entry, descent, and landing, it will be sending up UHF data in green, and the Marco satellites will be listening to that data and relaying it back to Earth almost real time, as was mentioned earlier. The InSight spacecraft is not dependent on Marco for its mission success. The Mars Reconnaissance Orbiter will be flying by, collecting that same data, but not relaying it until about 3 hours later. If it works, the 2 Marco spacecraft will relay the data for InSight entry, descent, and landing almost as it's happening, which would be very cool for both the Marco team and the InSight team to figure out what's going on with the lander as soon as possible. The Marco is a technology demonstration mission, so instead of having a science instrument on board, it has a whole bunch of different technologies that we're demonstrating, and I'll talk about those a little bit later, but if you put up the next image, please. We have an engineering camera on board, and the camera was put on board to verify the deployment of one of these new technologies, a reflector array antenna. And so in this image, on the right-hand side, you can see the actual antenna, the top third of that antenna, partially illuminated by the sun. On the left-hand side, you can see the antenna feed, also illuminated by the sun. And the cool thing about this picture, if you go to the next slide, There's Mars. It is the first image of Mars that was taken from a CubeSat. It was about 8 million miles away from Mars when this picture was taken. And so we're having fun with the camera. We'll see what we can do leading up to InSight EDL, but right now the team is focused on getting to EDL and supporting the InSight mission. So that's the closest thing we get to a kind of a selfie of Mars on orbit. We have a 2-scale model of MARCO here. So when I say it's a small satellite, I mean it. This is the actual size. When everything is folded up, it's about the size of a briefcase. Each MARCO satellite is about 30 pounds each, and the two satellites are virtually identical. And we fly 2 of them just in case one of them fails. We can have another one as backup. So this is the antenna that you saw in that image. It works a lot like the TV antennas you see on the side of a house. There's an active element here, the feed, that actually sends a signal. And then this, like the dish on the side of the house, reflects that and focuses the signal back to Earth. This antenna was specially engineered and designed to be completely flat, so it makes very efficient use of the volume and can fold up and fit very nicely on top of the spacecraft when it's all folded up for launch. The antenna that we use to listen to InSight is on the bottom here. It deploys out and is held in place by springs. This is tuned to the InSight UHF frequency, so as MARCO flies over Mars, it will be listening to that data from InSight, and then the radio on board, which is another new technology that MARCO is demonstrating, developed by JPL. That radio then takes that data and sends it back to Earth on a different frequency using this antenna. And the camera that took the image of these 2 objects is tucked away in the corner right there. So as I mentioned, MARCO has to do pretty much everything that InSight does. There's about half of the spacecraft volume is taken up by propellant. So MARCO has done its own trajectory correction maneuvers using fire extinguisher fluid. I'm not kidding. So we heat up the fluid, and it comes out as little tiny puffs, but that is enough to adjust the trajectory so that the MARCO satellites fly by Mars in the exact position and time that it needs to listen to the InSight signal as it lands. So there's tiny little thrusters on this side of the spacecraft that are used to do that. We also generate our own power. It is significantly less than what InSight mentioned. So we have 42 solar cells that generates about 17 watts of power, which is a couple nightlights. So not even a blender. So MARCO has crammed a lot of new technologies and new capabilities into a very small volume. The team is thrilled with how it's done so far. And given how well it's done so far, we're really hoping that this becomes a pathfinder for even more small satellites to go into interplanetary space. And we're excited for Monday. So back to you, Veronica.
All right, thank you, Anne. I'd like to invite all of the speakers to come back up on stage. We're going to take questions now. We will take questions here in the auditorium. We are also taking questions from the phone line from news media. If you are on that phone line, please hit *1. That will put you into the queue for the questions. We are also taking questions over social media. So if you have a question, I believe we've been requesting them all day already on social media, but if you have a question, post that to your social media account with #AskNASA. We will answer some of those during the briefing, and we will continue to answer those during the day, even after the broadcast. I'm going to start, let me check here to see if we have one in the auditorium. If not, I will go to the phone line. We're going to start with one here in the auditorium. Go ahead and state your name and affiliation, please.
Hi there. Ian O'Neill with Scientific American and HowStuffWorks.com. This is an EDL question, I suppose for Rob. How does the EDL for InSight differ from the Phoenix EDL?
That's a very good question. How does InSight EDL differ from Phoenix EDL? And the answer is very little. It is actually the spacecraft itself is nearly identical. There are a few differences, but the spacecraft itself is nearly identical. The difference in the landing challenge is that Phoenix was about a little more than 1.5 kilometers lower landing site elevation. So the InSight landing, we have a little bit less time to get things done. And that's probably one of the biggest things. The other is that we're landing during dust storm season, so we've had to design the system to be successful in a variety of different atmospheric conditions, although it looks like right now that we're not going to have any dust storm activity to deal with.
Thank you.
I'm going to take one more here in the audience.
Hi, I'm Ryan Blackshear Vargas from Spectrum News. Any chance that it'll land early or late?
Yeah, go ahead.
Sure. There is, if we're a little bit shallower, a little bit steeper in our entry flight path angle, and we have a little bit of tolerance there, we could land a little bit in different time. It can vary. The landing time can vary by about a minute or so, plus or minus, depending on what happens. The fact that we're kind of narrowed down and kind of know our atmosphere will make that uncertainty even less. So we're in good shape.
Okay, we're going to take one more here in the audience, and then I'll take a couple from the phone lines. If you're waiting on the phone line, please stand by. Go ahead.
Steve Gorman at Reuters. How high up will this will the spacecraft be at the time that it begins entry?
Go ahead, Rob.
Sure. Yeah. We generally consider it about 77 miles above the surface, or 125 kilometers.
Okay. And the decision on the final course correction will be made Friday, even though the correction, if you do it, the TCM will be done on Sunday. Is that right?
That's right. Yeah. Yep.
Do you know what time Friday we'll know?
Well, we have our decision meeting is in the early evening on Friday, so that's when we'll make the decision.
Thanks.
All right, I'm going to take a question from the phone line, and then we'll come back here into the room. But let's go ahead with Irish TV. Go ahead with your question.
Thanks very much, Veronica. It's Leo Enright here. I'm just wondering about the call-outs post-landing. I don't recall chewing my knuckles for 4 hours to know whether Phoenix had deployed its solar arrays. So I just wonder how the call-outs, the real-time call-outs, are going to work. How soon will we know that, for instance, the deployment has happened? All of that.
Yeah, so I'll address that question. The reason that we don't have immediate information about the solar arrays is, as Stu said, we have to wait literally for the dust to settle for about 16 minutes, and then it takes another 16 minutes or so for the solar arrays to actually deploy. At that point, MRO has gone behind Mars, so we can't get any more information up to MRO from the spacecraft. And Marcos have continued on their flyby, and they're also out of range. So the next orbital asset that we can communicate with is Odyssey, Mars Odyssey, and that comes up at about 5.5 hours after we land. So it's basically orbital dynamics is why we can't get information any sooner than that. With Phoenix, it was at the pole, so it got much more frequent overflights. So that was the main difference between InSight being at the equator, Phoenix being at the pole. So I think that...
I'll just add, Tom, that the solar arrays, the spacecraft's entirely capable of taking care of itself during that period. It'll autonomously command the deployment of the solar arrays, and if for some reason it doesn't correctly deploy them, it has opportunities, 3 more opportunities on its own to recommand those actuators to deploy those. So it's not like it's going to try once and then wait for the ground. It'll be on its own, and it's been tested and ready to fly that way.
So if I may follow up, we will know that the landing has been successful. We won't have to wait 5.5 hours for that, I hope.
Yeah, that's correct. We will, especially if the Marcos are working as planned, we'll get very close to real-time information that we've landed successfully. We also have on the spacecraft an X-band beep that we'll be sending roughly about 7 minutes after we land. That'll be the spacecraft telling the Earth that everything looks good. But then we'll have to wait for that Odyssey pass to finally know that the solar arrays have been fully deployed. And there's no getting around that, just its orbital dynamics.
All right, we're going to take one more question on the phone right now. Space News, go ahead with your question.
Hi, Jeff Faust of Space News. Question for Ann. I don't know if there's any thoughts about any sort of extended mission for the Marco CubeSats after the Mars flyby?
Not right now. The team is focusing on getting 2 EDL.
Hey, Jeff, that's the answer I asked to be given. No, I'm a strong believer that focus is what creates success. And I think you should know that we've had, of course, discussions about what's possible. And we're going to have these discussions at the back end of this exciting weekend.
Okay, one more phone call, and then we're going to go here in the room to social media, and then more questions from the audience. So we have AP on the phone line. Please go ahead.
Yes, hi. Marcia Dunn here for Rob. You mentioned it will be about 4 degrees Fahrenheit at touchdown. The press kit talks about 18 degrees. I'm wondering, do you have the latest forecast? Is that what's revising the temperatures down? And if so, what are the lowest lows going to be?
Well, I'm not actually the right person to know all that information. I got that estimate from our power engineer, the 4 Fahrenheit, which was actually at the lander deck height, and so I think it varies quite a bit depending on where you are above the surface. And so I think at night it could be as cold as 180 or something like that, minus 180 Fahrenheit.
Yeah, I think actually at the surface level it's closer to like 40 degrees Fahrenheit. So there is a huge variation just in that 3 feet. But one of the things we actually will be doing is we have a temperature sensor on board the spacecraft. We didn't really talk about that at all, but we have a bunch of sensors for pressure, wind, thermal that will be, and a magnetometer that we'll be using basically over the first week, especially to characterize our landing site. So we'll be able to give you a much better idea of what the temperature is every day.
Great, thanks.
Okay, we're going to take some questions from social now. So Stephanie, do you have some good questions coming in?
Absolutely. We're having an extremely lively discussion in the YouTube chat, and the Ask NASA questions are pouring in on Twitter. Laura Reeve on Twitter has a great question for mission managers here. On behalf of her middle school students, she asks, how does communication work between different parts of the design and building teams for a project like this, and how important is that communication?
I'll let Stu answer this as well, but that communication is critical, actually, especially as I mentioned, we have international partners, we have domestic partners, where very rarely are we all co-located together, so we have to come up with all kinds of different techniques and methods of communicating what's going on every single day. As we have design progressing or any issues that we have to work, we have to get together via all kinds of interactive things online, plus we try to do as many trips as we can to actually do face-to-face communication, because there's nothing really substitutes for that. So Stu, why don't you talk a little bit about what you do on the spacecraft side?
Yeah, definitely. I'm dating myself a little bit here, but I go all the way back to the Magellan time frame. And anytime there was a big critical meeting, the entire Lockheed Martin team would fly out to JPL or vice versa, and it was much more of a face-to-face environment. We still preserve that, but with the new technologies these days, we can all be at our home institutions, including our European partners, and get a lot done. And really, it's a good team environment where we're able to share information very collaboratively, and it's really a badgeless environment where everyone's working to a common goal, so there's no turf wars or anything like that. It's a good team.
All right, and we've got a question for Dr. Z. Martian Manish on Twitter would like to know, how will InSight help potential future human space exploration to the Red Planet?
What InSight will do is really give a much better understanding of the inside of the entire planet, and with it, as we're going to learn from the science panel coming right next, with it about the history of the planet and also its entire environment and geologically and otherwise. We will learn major ingredients about the history, but also the current state of the planet, its geology, and together with the information that we have at the surface, really get a much better understanding of the entire environment that will be faced by humans. That's what we want. Before we go with humans, we want to know everything. We want to know the radiation from the top. We want to know whether there's going to be volcanic activities from the bottom. We want to understand whether there's water on the surface, below the surface. We want to know whether there's resources. So it's just part of that knowledge that's such a critical element of human exploration.
And Anne made it clear that you're very focused on the Marco team on getting to EDL, but Emily Lochtawala from the Planetary Society in our YouTube chat is asking, what does happen to the Marco CubeSats after landing day, and how long can we remain in contact with them?
That's a good question. So the Marco satellites, they don't go into orbit. There's not enough of that fire extinguisher fluid on board to do that. So they will just fly by Mars, and they'll end up kind of in an orbit between Earth and Mars. And it will start getting farther and farther away, and I don't have a good timeline of how long we could actually get that signal, but eventually it will be too weak for us to actually be able to hear from it anymore.
Okay, we're going to take it back into the rest of the audience. We'll come back to social in just a couple minutes, and I understand we have a question here from ABC. Go ahead.
Hi, Stephen Coleman, KABC, Channel 7. What happens if one of the arrays, or both of them, fail to deploy? Can you continue the mission without them?
Yeah, so if we definitely need to have at least one of the solar arrays deployed because we are 100% solar powered. Our battery is not going to last more than about one Mars day without the solar arrays fully deployed. If we get partial deployment, we'll have to look and see exactly how much energy we are generating. Stu mentioned in his discussion that we have a little bit of variation in how much power we might see over the different points in time, so we're just going to have to take an engineering assessment and see what kind of emission we still have. But clearly, Lockheed Martin's done an excellent job of making sure that we are going to get those solar arrays deployed. So I have full confidence that that's going to happen, and hopefully we don't have to worry about any of the contingencies. I don't know, Stu, if you want to add anything?
No, that was well summarized. We've done a lot of testing during the first ATLO period, and then a bunch of retesting during the second integration and test period. So we're highly confident they're in good shape, and they're good to go.
Okay, we're going back to the phone line. Leo Enright has a follow-up question. Go ahead, Leo.
Thanks very much, Veronica. I hope this isn't too much detail, but in the video, we saw Marco doing real-time relay and MRO rising, but there seemed to be 3 MROs. Now, unless I've been asleep, there's only one. The 2 that I saw were middle and south. So I was a bit puzzled as to how come there's 3 MROs, or was there something I completely missed?
No, you did see 3 MROs. What that's representing is sort of the different times in which MRO might actually be visible depending on exactly when we're entering the atmosphere. So it's basically sort of a best case and middle case and worst case in terms of the coverage that we're going to get from MRO. So there really is only one MRO. It's sort of in that range of areas where it probably will be when we do our entry, descent, and landing.
Okay, any other questions in the room? If we don't have any other questions from media here in the room, go ahead. We'll take yours, and then we'll go back to social. Go ahead.
Did you say it'd be 4 hours or 5.5 hours, or is that a range for how long it would take?
I believe you're talking about when we're going to get information from Odyssey. It's going to be about 5.5 hours after touchdown.
Okay.
Okay, we have time for one more social question. Stephanie, go ahead.
All right. So Phil Moyer over on Twitter says, with InSight's design service life and given the record of your Mars probes far exceeding their expected lifetimes, how long do you think InSight will live?
Well, we have not designed any life-limiting features into InSight, so it's a function of how long we're going to continue to collect solar power and be able to run the mission that we want to run. We're designed to last 1 Mars year, so that's 26 Earth months. And so we think that with the accumulation of dust on the solar arrays that will make it at least 1 Mars year and get back to science that you're going to hear about in just a little bit. But we'll have to evaluate where we are after that year and how much science we've got back and make a case for continuing if we're making truly groundbreaking science that we expect to be getting.
Okay, we're going to wrap it up at this time with this panel describing the spacecraft. We are going to be back at the top of the hour at 11 a.m. Pacific time, 2 p.m. Eastern time to discuss the science of the mission and the science instruments. So there's a lot of really cool stuff on this spacecraft. Please come back. Also want to promote for you that the next news briefing following today will be on Sunday, just 1 day before landing, and we'll get a final update on the status of the spacecraft at that time. And then landing landing day again. It's Monday, November 26th. Our commentary will begin at 11 a.m. Pacific time, 2 p.m. Eastern time, with landing taking place about an hour later. And again, there's multiple websites where you can watch the landing live. You can go to nasa.gov/live if that's the easiest one for you to remember. On our toolkit page at go.nasa.gov/InSight Toolkit, you'll see two tabs there. One is how to watch online. It has a chart with numerous platforms where you can watch on YouTube, on Twitter, on Facebook. Again, our 360-degree broadcast will be on our YouTube channel. There's also how to watch the landing in person. There are numerous events taking place across the country. You can check from California to New York to Times Square in New York. You can even be standing there in Times Square and see our landing commentary on the NASDAQ Tower. There's even some viewing parties in Europe. So those are all marked, again, at that toolkit page. Just click on Watch in Person. We will resume at 11 a.m. So in the meantime, we're going to replay some of the videos for this particular mission, starting with a description again of entry, descent, and landing, and the nerve-wracking white-knuckle 6.5 minutes to get to the surface of Mars. So that'll wrap for now, and we'll be back in about 15 minutes. Thank you for joining us.